Hello, this is Lab Investigation 2.1. I'm sorry if you're quarantined, so we're just videoing these so you can answer the lab questions. So you're gonna follow along in the EWIT Lab Investigation 2.1 on Kimmy. It's also on the board. So Lil Lou is my cameraman. He's a great cameraman so far. Oh,
yeah.
Okay, so number 1 says, carefully examine the ammeter. How is it similar to other scientific tools like a thermometer or a graduated cylinder? So Lulu, can you come in here? So your ammeter is measured in milliamperes, and so it starts at 0, goes all the way to 500. The red is the positive terminal, the black is the negative terminal. So you have little tick marks here. From the 0 to the 100, you have 10 tick marks. So that means that the small tick mark is going to be 10 milliamperes. So the units are little m, big A. Okay, thank you, little Lou.
Got you.
So you're answering now number 1 and number 2. So how is the ammeter different from other scientific tools you've seen? So you can pause your video and then come back after you answer those questions. Okay, so the next part says ammeters are used to measure the flow of charge in an electric circuit. Read Building Your Knowledge, How Electrical Devices Work on page 27 in the Lesson 2 book on CarolinaScienceOnline.com to learn more about the flow of electric charge and how it's measured. So you'll need to read that. And you'll follow these directions to get to the book. If the lesson 2 book is not on there, email me and let me know. Just make sure you do not submit on CarolinaScienceOnline.com. So you're going to answer, what units of current does your ammeter measure? So you can look here again. And you see it's milliamperes. You can just put a little m and a big A. What's the range of your ammeter scale? So come back. So it's 0 milliamperes to 500 milliamperes. How much current does the smallest interval on your ammeter represent? So we said that these little intervals are going to be 10 milliamperes because you've got 10 of the little intervals, and then so between 0 and 100 there are 10 intervals, and so each one is 10 milliamperes. So we are now going to number 5. So hello again. So look at the component symbols on your EWIT lesson 2 jot chart and graphic organizer and find the symbols for the bulb, ammeter, switch, and battery. Starting with the battery and then going to the bulb, list the order in which the components are seen in the figure above. So this is the figure you're looking at. So you have a battery, a bulb, the ammeter, and a switch. And something important to know is our positive end of our battery needs to be connected to the positive end of our ammeter. So let's look over here, little Lou. So this is the positive end of my battery. So the part of the battery that has the little nodule at the end, that's the positive end. So I'm going to connect the positive end of the battery to the light bulb, and then the light bulb will go to the positive end of the ammeter, and then I need to connect it to the switch. So anytime that you are connecting things, you need to have your switch open. And so here is the negative end, and then you want to zoom out to see the whole thing. And then I'm going to connect the switch to the negative end of the battery. Okay, so number 6, you're trying to, so it says starting with the battery and then going to the bulb, list the order in which the components are seen in the figure above. So you're going to go battery, bulb, ammeter, switch. So you can just show it large now.
Okay.
And then to measure current accurately, you must connect the ammeter correctly. So that's what we did. It must be in a circuit with another device, and it must be connected to that positive terminal on the ammeter, or connected so that the positive terminal on the ammeter is connected to the positive terminal on the battery, which is what we did. Now it says close the switch. What is the current running through the ammeter? So I'm going to close it. So zoom, like have all of this in the shot. So now I'm closing it. And our ammeter moved up to, it looks like it's going between 120 and 130. So I would put that it's 125 milliamperes. So you would say 120 little m, big A. So what do you think the current is like in different locations in the circuit? Is it the same or does it change? So you're going to answer that right now. So what do you think? So you're making a prediction. If you think, so if I move this ammeter, instead of it being between the bulb and the switch, if I moved it between the battery and the bulb, and you can see the bulb is turned on a little bit. I hope you can see that in the video. Can you see it, little Lou?
A little bit.
Okay. So if you move the ammeter between the battery and the bulb, instead of it being between the bulb and the circuit, what do you think that the ammeter will measure that 120 milliamps here as it does here? So you're going to answer that right now. What do you think it's going to measure in the different locations? Okay, so if you pause it and you're back, welcome back. So we're on number 9 now. How could you use the ammeter to measure current in a different location? So we could change where the ammeter is located, right? So anytime I want to move connections around, I want to open my switch. And so I'm gonna move my ammeter right now. Like I said, I want to put it between the battery and the bulb. So that's where I'm moving. So still positive end of the battery to the positive terminal. Okay, so now it's between the battery and the bulb. So now we're going to close the switch again. And it should measure about the same, which it's a little bit at like 135 maybe. That's not enough difference for it to be different than what the ammeter measured. So number 9 says, how could you use the ammeter to measure current in a different location? Well, we moved the ammeter to a different location. Number 10 says, scientists frequently make predictions about the systems they study. A prediction is an educated guess about the outcomes of a situation. What do you think the current would be if you moved the ammeter to a new location? So we should have done our prediction before now, but look back at what you predicted and write your prediction as an if-then statement. So you would say, if we move the ammeter to a different location, then the current will, and this is where you would predict whether you stay the same or if the current changes, if you moved it to a different location. So number 11 says, move the ammeter to a new location in the circuit and list the order in which each component is located in the system of the circuit. So we moved it. So now it's battery, ammeter, bulb, switch. So you're going to list that in order. And we close the switch and we record the current through the ammeter. So again, our current is about 130 milliamps. So make sure you put your units there. Okay, and then number 13. So we're videoing in second period right now, and I think second period got to number 13. Was that right? Yes. Okay, so we're on number 13 now. So y'all work with me. So it says, open the switch and consider how reversing the battery connections might affect the current through the ammeter. The negative battery terminal will be connected to the positive terminal on the ammeter. Write your predictions using the words if and then. So right now you're going to say, if we switch the terminals with the positive terminal being swapped to the negative terminal, comma, then what will it register? So you're answering what will it register in the then part. So answer that now. So you should be answering number 13 now. So we're caught up now in the class. So while they're doing that, I'm going to open the switch and swap the terminals around. So now my positive end will be connected to the negative. So the positive is going all the way, so positive is going all the way to the negative. And now the positive terminal of the ammeter is going to the negative terminal on the battery. Okay, and so you stay right here, Lulu. So we're answering number 14 now. We're gonna close the switch and record the current through the ammeter. So now that I've swapped the terminals, I'm gonna close the switch. So watch what happens to the ammeter. Okay, so it actually went to negative below the zero. So it's below the zero, so that's a negative number. So when we close the switch, the ammeter changed to a negative. Whereas when the flow was going properly, it was a positive 130. So now you're going to answer another what do you think question. So what do you think happens to the current in a circuit? Is it lost or used up? What do you think? Answer number 15 now. So what do you think? Do you think it's lost or used up? So answer that. Okay, number 16 says, what evidence from your investigation supports your claims? So what evidence do you have? So when this was connected properly, so I'm going to connect it back properly. So positive to the positive, so positive is all the way to the positive. Negative, so negative is running back to the negative. So electrons are flowing from the positive to the negative end. So it says, what evidence from your investigation supports your claim that that current is either lost or used up? So the evidence that we saw is that when we have the battery and the ammeter connected properly and we close the switch, the light comes on and the ammeter registers a positive number. In this case, it looks to be about positive 150. It's changing just a little bit as we move things around, and what's happening is the connections get better or worse. So that's why you're seeing a little discrepancy in the numbers each time. But what evidence do we have that showed you that current is lost or used up? So we saw that the ammeter registers a positive number when current flows the proper direction. Also, we swapped the terminals in the battery and it's flowing a different direction and the ammeter registered a negative number. So also answer, what did we do in the investigation to show that the current is the same regardless of where it's placed in the circuit? So also answer that. So remember, we had the ammeter between the bulb and the switch first. Then we moved the ammeter between the battery and the bulb, and the current registered pretty much the same. Again, there might be a little difference, and that's just because the connections are there better now when I unclip the alligator clips. Number 17 says, what do you think would happen to the current if you added more batteries to the circuit? So remember that this battery is a 1.5 volt. You can see the connections are loosening up a little bit as I move it. But this battery is a 1.5 volt. What if we took another battery that's a 1.5 volt and put it in another battery holder and then connected these together so that 3 volts is going through the circuit instead of 1.5 volts. So you're answering number 17. What do you think would happen to the current if you added more batteries to the circuit? So it's not added right now, but what do you think would happen if we would add it? Would the ammeter register more or less, or would it stay the same? Would the light bulb get brighter or dimmer? What do you think? So that's the end of Lab Investigation 2.1. So once you finish answering that, you want to click Turn It In and turn it in again and then submit it. If you're having problems submitting it, make sure you download the CAMI file onto your Google Drive. So you're going to download it with the answers that you put in and then go back to the assignment to where it says Submit Assignment, click Submit Assignment, find it in your Google Drive, and then upload it that way. Thank you for listening. I hope y'all are all doing well at home, and I look forward to seeing you again soon. Bye.